Hey, I want to just take a moment and talk about the desired outcome of this presentation. Cormac asked me to provide a technical presentation from Oracle. Unfortunately, I did review the available public domain presentations. Nothing was really recent or well done. I do have a couple press interviews that I'll share the links for in this email. However, all of my Oracle presentations were marked internal or confidential. So I decided to build a presentation. So this will demonstrate not only my ability to present technical content, it'll also demonstrate my ability to create slides, speaker notes, choose graphics, talk about a complex subject in order to demonstrate what I think is the most important skill of this role. So really worthwhile endeavor. I did spend Sunday writing this presentation. I'm not an expert. I did scope it for about a 13 to 17-minute presentation, not to force you to watch me for a half hour. So really kind of an overview of what I can do for you and your organization. I hope you enjoy it. I'm going to pause for a second and then kind of formally start the presentation. Hi, welcome. Today I'm going to talk about IT architectures available to companies and organizations today looking for creative or cost-effective high-performance computing solutions. We'll be addressing the three core technologies of cloud, edge, and on-premise compute solutions, as well as combinations and hybrids of some of those. We'll be reviewing the benefits, the exposures, use cases, and special considerations like security, latency, where the best solution for each customer use case would be. I hope by the end of this presentation you feel comfortable looking at the mosaic of offers available to you and are able to architect and put together a solution with me to help provide you the best compute power for the most highest payback of your IT dollar. In today's economy, IT leaders have three distinct core architectures to help solve their difficult compute problems and provide high performance, cost effective solutions to solve the solutions to the problems they're having today. In most companies, cloud, edge, and on-premise architectures will work together to meet diverse company requirements and end user compute needs. Cloud solutions offer remote support for scalable solutions with high performance and shared tenancy for cost efficiency. Edge computing brings the computing closer to the devices for real-time responsiveness and low latency communications, while on-prem systems still provide full control for legacy compliance and environments where customers want to create competitive advantages with compute strategies. Today, we will explore how they can use these technologies to build a hybrid ecosystem with cloud for scale, edge for speed, and on-prem for competitive advantage and governance. Smart orchestration across these layers enable optimized performance, cost, and compliance. Let's take a closer look at these core compute archetypes as we go through the remainder of this presentation. Cloud computing can provide significant benefits to the organizations of today. There are basically two flavors of remote cloud computing: dedicated or single tenant, and shared servers, multi-tenant operations. Single tenant or dedicated cloud servers offer exclusive resources for one organization, ensuring consistent performance and strong security. This setup supports high demand scalable workloads with greater control over configuration and management. However, it does come with a much higher cost than a shared remote resource. Remote dedicated cloud servers users benefit from tailored scalable solutions that demand reliable service quality, managed with regular updates, backups, and continuous monitoring to maintain end user peak performance. But being a single tenant on a remote server or collection of servers may bring unwanted challenges of high cost and potentially high latency due to the remote location of these servers. In order to address these higher costs, cloud service providers have provided multi-tenant or shared tenancy cloud solution. In this environment, multiple corporations and companies will share the server hardware across different applications, users, or companies, thus increasing server utilization and driving down per customer costs. While this model offers dynamic scalability and efficiency for supporting variable tenant workloads, it can impact performance, making proactive allocation and performance control essential to maintain minimal acceptable service levels. Since several users will share the server environment, security and allocation management require careful and constant attention. Reliable isolation mechanisms are required to protect sensitive applications and tenant data. All the while, remote server teams will monitor workloads, ensure scalabilities, and conduct regular allocation and security audits. Efficient resource allocation and strong governance are key to balancing the affordability with this improved reliability. All of these environmental controls, scaling controls, protections, and controls will tax available CPU performance. Therefore, total server utilization will be less than that in a dedicated or single-tenant environment. However, the cost advantages are significant. I would say the majority of cloud-deployed solutions today are in shared tenant applications where performance and management and governance are not as strict as they would be for dedicated. Cloud computing is all the rage. However, there is still a compelling argument for local servers or edge devices, basically in-house servers or near source servers. On-prem infrastructure gives today's organizations full control over their computing environment, allowing servers to be tailored to specific performance needs. Alternatively, local edge servers can provide extremely low latency server client support for real-time or fast, low latency communications. The local nature of this solution delivers responsiveness and maximum compliance with internal policy and global regulatory standards. This solution is ideal for industries with strict governance requirements or the need to create real-time compute, or if the competitive advantage of the company is through aggressive compute strategies. Be aware, this local control comes with a higher upfront cost, increased ongoing maintenance demands, as internal IT teams must manage the hardware and ensure software compliance. They'll also maintain security through isolation mechanisms and regular routine audits and maintenance. On-prem remains the leading strategic choice for real-time low latency systems and sensitive workloads, but they do require tight organizational oversight. So the market requirements of these high-performance solutions must demand this type of solution. So cloud computing is extremely popular right now. To fully enjoy the best of all the available technologies, most large organizations and strategic organizations see the need for a hybrid compute solution. A hybrid architecture blends cloud, edge, and on-premise computing to create flexible, scalable, resilient, low-cost IT environments. By processing data at the edge close to its source, end users and organizations reduce latency. They enable faster decision making, especially for real-time or location-sensitive workloads like financial transactions or real-time controls. For cost optimization, you can port activity to the shared cloud tenancy for task and exception-based events, while cloud data backup can ensure scalable storage for disaster recovery and business continuity. Providing this layered approach balances performance, control, and efficiency across all the diverse compute needs of any large strategic organization. Now that we laid a foundation of the available options for customers, as well as compute solutions for corporations, I want to explore some different use cases, some special benefits, and well as some considerations available in this solution mix. Let's take a moment to overview some specific use cases powered by edge and hybrid models. Edge and hybrid architectures unlock a powerful combination punch by unifying local responsiveness and scalable infrastructure. Edge computing supports real-time IoT analytics and low-latency applications by processing the data near the source. For critical time-sensitive operations like financial transactions, industrial automation, smart cities, and connected healthcare. while the hybrid model complements the edge on-prem solution by distributing larger workloads across the cloud, enhancing disaster recovery and workload balancing. This approach can ensure that business continuity, optimize resource application, and supportive dynamic scaling for modern enterprises will meet all the compute demands. There are some specialized performance and differentiated cloud solution advantages. Edge computing powers real-time IoT and low latency apps by processing data locally, reducing delay and bandwidth use. Perfect for IoT node support and monitoring, where cloud computing excels at large language models, artificial intelligence with big data analyticals, and scalable resources. While the on-prem infrastructure secures sensitive workloads through full control and customization. Together, these models offer optimized performance, edge for responsiveness, cloud for scale, on-prem for secret sauce and competitive advantage. A multifaceted approach will give today's businesses the flexibility to adapt, compete effectively, and manage IT costs. Truly the best of all worlds. Now that we're advocating this large interconnected solution of on-prem, edge, and cloud, we do have to mention the increase in security vulnerabilities. With the increase in cross-system communications, there are system risks that need to be addressed and managed. Edge and hybrid architectures introduce a broad portfolio of attack surfaces due to their distributed nature. Each node becomes a potential entry point and must be monitored for malicious threats. As systems scale across cloud, edge, and on-prem environments, the complexity of integration increases, creating more opportunities for misconfigurations and support vulnerabilities. To mitigate these risks, organizations must implement a robust architecture and security strategy. This should include securing each node, enforcing strict access control, ensuring seamless and secure integration across platforms, proactive monitoring, and regular audits. These are essential to maintain resilience in these dynamic environments. If you can address these security vulnerabilities, you can enjoy the benefits of a broad-scale hybrid solution. Today's presentation would not be complete without addressing optimal CPU choices. Focusing on critical considerations when architecting your hybrid IT solution, CPU and other supporting component choices are paramount. All servers will not provide the same performance, and older or inferior CPUs will significantly impact your company's competitiveness, your end users' efficiency, and may increase your subscription IT budget. Consider, cloud services rely on numerous multi-core, high-frequency CPUs to efficiently process, manage parallel workloads at scale with nonstop performance across dynamically changing environments. This makes them ideal for compute-intensive tasks like big data analyticals, AI, processing on older technologies akin to putting an old engine in a new race car. The outdated CPU will run the subscription meter higher and longer, delaying your company's ability to iterate models and resulting in paying higher CPU time fees. In contrast, edge and on-prem systems require a more bespoke or specialized CPU configuration to the task at hand. Edge servers need to prioritize power efficiency, low latency for real-time responsiveness, while on-prem CPUs are optimized for performance and reliability for workload-specific requirements. With the added need for seamless integration, ensuring minimal downtime and long-term scalability of your entire compute environment. So knowing what CPUs and components your solution is riding on is critical to optimize your performance and minimize your costs. Now, building on your knowledge of today's available solutions, let's talk a little bit about some emerging trends. like serverless computing and multi-cloud packaging strategies. They're reshaping how applications are built, deployed, and supported across hybrid environments. First, serverless computing. This is a cloud-native model where developers write and deploy code without managing the servers or the infrastructure. In this environment, developers can laser focus on code without managing the infrastructure, leading to greater scalability, faster development cycles, and reduced operational overhead. This model is ideal for dynamic workloads and event-driven applications. No longer will IT support staff be provisioning or deprovisioning or scaling servers manually. The cloud service provider will automatically now handle those tasks, allocating server resources only when the code is triggered. Multi-cloud strategies are a way to reduce your overall cloud cost by adding enhanced security frameworks. By leveraging multiple cloud providers, organizations can optimize performance, control costs, and avoid vendor lock-in. At the same time, advanced security frameworks are essential to protect data and ensure compliance, especially in complex multi-tenant environments. This basically makes remote cloud applications more secure and portable in IT organizations to allow IT users to easily migrate to lower cost cloud offers as their IT structures require. It breaks the lock-in requirements around cloud contracts and allows customers to spot shop CPU resources to enjoy the greatest value for their IT dollar. So in conclusion, selecting the optimal IT and architecture requires evaluating performance, security, cost, and manageability in the context of your organizational goals. Cloud, edge, on-prem all offer unique advantages, but the greatest flexible solutions span all three of these offerings into a hybrid solution. I would welcome the opportunity to meet with you to further discuss how we can help provide you the services and subject matter expertise to optimize our compute strategy.